Our project was a fuel cell powered locomotive sponsored by Wabtec. For a little background on Wabtec and the project itself, Wabtec is one of the industry leaders in creating freight and passenger transportation. Considering the cost of diesel and the amount of carbon dioxide emissions released, Wabtec has chosen to pursue fuel cells. Those fuel cells in the future will greatly reduce the amount of carbon dioxide emissions for the locomotive industry. From the information given by Wabtec, we have developed a problem statement to design a fuel cell configuration to replace the engine and the alternator while retaining the capabilities of current locomotives. The objectives for our project were to determine the best fuel cell for the locomotive that will retain the capabilities and to find a supplier for said fuel cell, to determine the quantity and configuration of fuel cells to power the locomotive, size the radiator to provide sufficient heat removal, calculate amount of fuel required for the same range as the current diesel locomotive, and to determine if a supplemental battery will be needed. For the 6 different types of fuel cells listed below, the different types of fuels that can be used are hydrogen, methanol, natural gas, and biogas. The different catalysts are platinum, nickel, copper, and cobalt, and between all of the fuel cells, they can range from a temperature of 40 degrees Celsius to 1000 degrees Celsius. For our project, we chose a polymer electrolyte membrane fuel cell, which has a water-based acidic polymer membrane electrolyte, operating temperature between 80 and 100 degrees Celsius, hydrogen as its fuel, and platinum as its catalyst. It is currently used in automobiles and material handling vehicles. Down below is an image of how a fuel cell works. It is shown that it takes in hydrogen and oxygen and outputs water and the excess hydrogen, which is then reused. We chose this fuel cell because of our specs based on temperature, size, and power output were fulfilled.
This is the general layout for a fuel cell system. The boxes in gray are not considered because they are out of the scope of our project. The boxes in white are the components we analyzed. A supplier was found to ensure the fuel cells would work in the locomotive. 28 of the PM fuel cells was needed to supply the 4,500 horsepower. 2 of them would need to be wired in parallel with 14 in series, and that is a top-down view of the area that we have for our fuel cell system. A radiator was sized to fit into the locomotive based on the specifications given from Wabtec and the requirements for the fuel cell to operate properly. We determined that there was not enough space for the hydrogen fuel, so we would need a tanker, and a supplemental battery would be needed if the fuel cells would fail, and it would also be used as a starter. Thank you for watching our video.